Alright, so the movie I had was N is a Number, a portrait of Paul Erdos. I'm Nathan Wollack. So a little bit about Paul Erdos. He was a Hungarian mathematician known for his immense number of proofs for seemingly impossible problems. He lived from 1913 to 1996. He was born in Budapest, Hungary, and died in Warsaw, Poland, during a mathematical conference where he was giving a lecture, which is kind of what he said he wanted to go out doing. He wanted to be giving a lecture and just kind of kneel over during that point. Throughout his lifetime, he published around 1,500 mathematical papers, mostly in the field of theoretical math, so like discrete math, number theory, stuff like that. He believed in an extrinsic or collaborative view of mathematics, working with roughly 450 other people in his lifetime. And the kind of joke he has with it is the Erdos number. So Paul Erdos has an Erdos number of 0, and everyone who's collaborated with him has an Erdos number of 1, and everyone who's collaborated with someone who collaborated with someone who collaborated with Erdos has like a number of 2 or something like that. And then he had very few worldly possessions, no home, and he did not stay tied down to a job. He didn't marry, nothing like that. Most of his life was devoted to mathematics and proving theories. He's kind of called like the bumblebee of math, floating from different university to university, teaching about the math. So the summary of the movie, it's a documentary on the life of Paul Erdos, giving like the overall story of his life. All the actors in the movie were people that Erdos had collaborated with and Erdos himself. And the movie just follows Erdos as he travels around the world meeting with his collaborators. So I ended up giving the movie 3.5 N's out of 5. So for being a documentary, I was much more engaged than I normally would be with like other documentaries. The one like downside of it being a documentary was there was no real plot in it, but there was a little bit of comedy just because Erdos liked comedy in his math. So talking about like how he didn't butter his own bread until he was 21 and the Erdos number and stuff like that. I did wish there was more actual math shown in the movie rather than the smaller mentions of it, and it was sometimes difficult to understand what people were saying without subtitles just because they're from Hungary and they have accents. So the first ever paper that Erdos wrote was on Bertrand's postulate. Bertrand's postulate states that for any integer n, where n is greater than 0, there is a prime number p, where n is less than p, which is less than or equal to 2n. And this was verified by Bertrand for n is less than 3 million in 1845. So yeah, Erdos wrote his first ever paper on the topic, giving a proof for much larger numbers. He used the central binomial coefficient, which is, it's written like this or something, which is really equal to 2n factorial over n factorial squared. And he said that if there is no prime between n and 2n, an upper bound can be placed on the central binomial coefficient that is less than 4 raised to the n divided by 2n plus 1. And then he also used this equation, O sub p to the n, which represents the largest prime number p, the exponent that divides the integer n. So when you plug in the central binomial coefficient for n into this, in order for there not to be a prime number between n and 2n, all the prime factors of the coefficient must lie between 2 and 2n divided by 3. So a prime factor, like prime factors of 10 are 2 and 5, of 6 are 2 and 3, stuff like that. And then he used this to prove that Bertrand's postulate was correct for n is greater than or equal to 468. So any number above that, he could prove that, and then you can do all the smaller ones by hand. So like between 2 and 4 is 3 and stuff like that. The other mentioned math in the movie was Ramsey's theory. This states that for each pair of positive integers, typically represented by R and S, there exists an integer such that any graph of the Ramsey number R of S of S has that number of nodes, and it has an R number of nodes in a clique and an S number of nodes in an independent set. So for a clique, that is, so say it's R, 3, and 3. So you want 3 dots that form a clique. So they're all together, and then 3 that are exclusive from each other, so they're not ever connected to each other. So yeah, there's no actual formula to calculate the minimum number of nodes required when given an R and an S. However, there are bounds, and Erdos focused mainly on Ramsey numbers that had an R equal to S, so like 3 and 3. Then he used his probabilistic method to get a range for each Ramsey number, so that was like the base for it, the relationship, and then he used that to get the lower bound and that to get the upper bound. So like for this one, this is equal to 6. So you have 6 nodes, and say you have 2 different colors or 2 different line shapes. Well, in order for there to be that and like something like this, where none of them are touched, like to get at least one triangle, I think how he describes it in the movie is, say you go to a party with 6 people, how many people need to be in the circle for at least 3 people to know each other, or 3 people not to know each other. So if the dotted lines are represented by people knowing each other, like all 3 of them know each other, you need at least 6 people for this to be possible. And so you can do this with any numbers in here, but most of them haven't been solved yet. Like I think the highest you can go is like R4 and 4 is the highest that's been proved so far, which is like 18. But R5 and 5 is somewhere between like 63 and 68, which he used those bounds to calculate. So the frustrations I had with the project was not a lot of the math was actually in the movie, and like the basic concept of the math was pretty easy, but the proofs that he did had a lot of symbolism that I didn't even know where to start with. And then Erdos mostly did proofs rather than coming up with his own theorems, which made it difficult for me to really choose what to do for the math. And any questions?